Hey folks, how's it going? This is Mr. Murray coming to you with a due now for Course 2 Honors for Tuesday, April 28th, 2020. So I'm so excited to be getting back into things and to be introducing to us radians, this new idea of measuring area and measuring angles actually too. Mostly angles, but it leads to area, okay? So in any case, this was something we talked about the Wednesday before April break, but I thought that I would pose this again to give us a chance to think through this, okay? Because at the end of this activity today, we're going to be answering a similar question, except using a different way to measure angles, okay? So the first thing is we need to refresh our memory. I want you to do this. I want you to write the area and the circumference, so that's part one. And the second part of this due now is to try to answer this question. Okay, so at Monsieur Moret's mathematical masterpieces, slices of pie are priced based on the length of the crust. So that is to say, all of the pricing is the same, so therefore the longer crust will always cost more, regardless of the pie. Okay, pies come in two sizes: child size, which has 3 inches radius, and adult size, which has 6 inches radius. Okay, today, sisters Hadley and Avery are checking out the boysenberry bonanza. Hadley cuts a nice big slice of the child-sized pie with the two straight sides of the slice forming a 120-degree angle. Avery then cuts a slice of the adult-sized pie, making a smaller 45-degree angle with the straight sides of the slice. Question is, who gets more pie and who pays more money? Okay, so in other words, who's getting more area, actual substance, and who's getting more crust? Okay, so what I want you to do is this: pause the video, get me the area and the circumference of any circle in general, then use what we know about arc length and sector area to answer this question, and then when you're ready, unpause and you can see what I got. Okay, so this is really important, and I believe in the lesson notes for today how important this is, because this is really going to be a great introduction for what we're going to do today. So the idea here is, well, first of all, we know the area of any circle is equal to pi times the radius squared, and the circumference is equal to 2 times pi times the radius. If you said pi times the diameter, good. We do want to have it framed in terms of the radius, because that's what we're being given. Right, that is to say, we know that, we know the child size will be 3 inches, while the adult size will be 6 inches. Okay, so we need to know who gets more pie and who pays more. That is to say, who has more crust. Because whoever has more crust, in other words, whoever arc length is longer, pays more, okay? And who's ever got more sector area gets more actual pie. Okay, so basically here's the idea. Remember that I have first step is you take the number of degrees and you divide by the total degrees in a circle, and that's 360. So that's, in other words, a third. Okay, the second step is you find the area of the entire thing. So if the radius is 3, the area would be pi times 3 squared, or 9 pi. And if the radius is 3 and the circumference is 2 times 3 times pi, so it's 6, right? Because 2 times 3 is 6 pi. Okay, step 3 is to take the ratio from the first step and multiply it by the area. So that is to say, if 120 is a third of the total degree measurement of the circle, then the area is a third of the total area, and the arc is a third of the total circumference. So a third of 9 pi is 3 pi, so this is area, and this is the length of the arc is a third of 6 pi, so it's 2 pi. Okay, over on Avery's end, so we have, first of all, 45. We take the angle measure and we take it out of the total of the circle, right? 45 degrees out of 360. So if you do this on your calculator, you'd get 0.125. Make sure you do math, enter to fraction, and then enter again, and it will actually convert it into a fraction for you. So you'll see your calculator will say 1/8. Okay, if you know that without needing a calc, that's okay too. Okay, step 2, we're going to calculate the area and the circumference, the total area. So we know that the radius is 6, so the area is pi times 6 squared, or 36 pi, and the circumference is 2 times pi times the radius. In other words, 2 times 6, which is 12, times pi. All right, last step, we're going to take each one of these and we're going to multiply it by an eighth rather. So 36 pi times an eighth would give me 4.5 pi. Okay, because remember, because the angle is an eighth of the total angle, the area of the sector is an eighth of the total area, and the length of the arc is an eighth of the total circumference. So we're going to do 12 divided by 8, and we get 1.5 pi. Okay, and if you want to get an estimate of what these are, that's actually okay, but you don't need to because we're only looking at the purposes of comparison. So whichever coefficient is higher, it doesn't matter what pi is, right? If it was x, if it was p, if it was l, if it was z, if it was q, if it was t, it doesn't matter, okay, you see, because if you have 4.5 of something, you're always having more, you're always better off than if you have 3 of something, okay? In this case, because we're using positive numbers, okay? So, if we also should be technical and note that any area should be in inches squared, and any circumference or any length should be in inches. So it's inches squared in inches. Okay, this is inches squared in inches, inches squared in inches, or SQIN instead of inches squared. So who gets more pi? Avery gets more pi. Okay, she actually gets 1.5 times as much pi as Hadley does, right? She gets 4.5 compared to her 3, and Hadley pays more money. Okay, because Hadley has more crust than Avery does. Okay? So this is just a problem to get you guys thinking about arc length and sector area. These are two extremely important ideas that involve circles. Okay, today we're going to start taking it one step further, and again, like I said, we're going to introduce a new way to measure angles, and by introducing that measurement system, we're going to not only see a way of measuring angles that's kind of like unique and cool and works for all kinds of applications where degrees might seem more arbitrary, but also we're going to see how the problem solving process is basically exactly the same. Okay, so it's going to get you thinking about next year and the future, because in many problems in contexts you can actually only use radians, whereas even with degrees you can convert and use radians. Okay, it's going to be something that's going to be real cool. So I hope that you really enjoy the activities. Keep it up. Don't forget to love math, folks. I'm looking forward to seeing everyone tomorrow for the Google Hangout. And remember, you can do it. All right, have a wonderful day. I'll see you next time, folks.